This video we shall discuss a further pure paper 1 2022 October November paper 11. Let's take a look at question number 1. We have a cubic equations x cubed plus bs squared plus d equal to 0, and it has the root of alpha beta gamma where the alpha beta equal to 0 and the d is not equal to 0. Alpha equal to beta and the d not equal to 0. So over here, what we can do is we can just list out the relationship over here. Alpha plus beta plus gamma is actually a negative b. Then the alpha, beta, alpha, gamma, and plus the beta gamma is a 0. And the alpha, beta, gamma is a negative d. Okay, so first of all, we list out these three relationships first. Okay, so because of given alpha equal to beta, so from the first equations, you will have 2 alpha plus gamma is equal to the negative b. And then from the second relationships over here, you get alpha squared plus 2 alpha gamma equal to 0. You can factorize it out. Then the third relationship, you can see that you have alpha squared gamma is equal to the negative d. Okay, so I think over here, the middle one, the relationship over here, it looks more useful for us at the moment because we know it's equal to 0. So if we know equal to 0, that means alpha is a 0 and alpha is a negative 2 gamma. But this one had to be rejected or ignored. Why reject? Because alpha equal to 0, that will give you the d will be a 0. Okay, the d is a 0. If alpha is a 0, that means the d is a 0. But the d cannot be 0. D cannot be 0 means alpha cannot be 0. So that is why we reject alpha equal to 0. So because of the d not equal to 0. So that means your alpha has to be negative 2 gamma. So over here, I call this one equation 1. I call this one equation 2. I call this one equation 3. So equations 1, we just substitute 2 into 1. You will get negative 4 gamma plus gamma is equal to the negative b. So your gamma is actually b over 3. Okay, your gamma is a b over 3. So if your gamma is b over 3, then from equation 2, your alpha will be the negative 2 over 3 b. Okay, then from equation 3, you have alpha square gamma is equal to negative d. So this one is the negative 2b over 3. b over 3, you get 4b cubed over 27 is equal to the negative d. Therefore, you get a 4b cubed plus the 27d is equal to 0 shown. So this is how you get the answer for the part A. Okay, then now we move on to the part B. So they give you this relationship. Another relationship is 2 alpha squared plus gamma squared is equals to 3b. So from part A, equations, just now what is alpha? Alpha is negative b over 3. And gamma is a b over 3. So you have 2 alpha negative b over 3. Sorry, negative 2b over 3. So you get this as the 9b squared over wait for a while. 3b. Oh, okay. Your alpha square is a negative 2b over 3 plus the gamma is b over 3 is equal to the 3b. So you will be having 9b square over 9 is equal to the 3b. So you will get b square minus a 3b is equal to 0. Factorize the b out. You get the b is equal to 0 and the b is equal to 3. So for same reason, we reject the b equal to 0. Reject the b equal to 0 because of b not equal to 0. So our b has to be 3. Okay, our b has to be 3. So we have found the b3. So from the result of a just now, the result is a 4b cubed plus the 27d equal to 0. So it will be 4-3 cubed plus the 27d equal to 0. Then your d is equal to the negative 4. Done. That will be the answer for the part B. So now we move on. Question number 2. The induction that for all positive integers, this relationship is divisible by 48. So we just say that when start from n equal to 1, so it will be, okay, I think, first of all, I will let this one call the functions of n. It's a 7 power 2n plus the 97 power n minus a 50. Okay, first of all, we do like this. Then when n is equal to 1, so you have a f1 is equal to the 7 power 2 plus 97 minus 50. So you get 96. 96, is it divisible by 8? Divisible by 48. Okay. Therefore, true for n equal to 1. Then we assume true for n equal to k. That means the fk, which is equal to the 2 power 7k plus the 97 power k minus 50 is divisible by 48. So now we go for the n equal to k plus 1. We take the fk plus 1 minus the fk. That will be the 7 power of 2k plus 1 plus the 97 of multiplied by k plus 1 minus the 50 minus a 7 power 2k plus a 97k minus a 50. So you can see that this one can cancel off. So you will get this as the 7 power 2k. If you factorize it, you will get 49 minus 1 plus the 97. You get k plus 1 minus k. Oh, sorry, 97 power k, not power, not multiply. This one is power k. So this one, it will be 97 power k of 97 minus 1. So you get this as a 48. 7 power 2k plus the 97 k multiplied by 2. Okay. So your fk plus 1 is equal to the 48, 7 power 2k plus 2 times of the 97 power k plus the fk. Okay, so you can see that this is multiple of 48, which means it's divisible by 48. This one, in the second statement, we already know that fk is divisible by 48. Okay, so over here, for this reason, you can just say that fk plus 1 is divisible by 48. So we have proven true for n equal to k plus 1. So conclusion, by the BMI, the Fn, which is a 7 power 2n plus the 97 power n minus a 50, is divisible by 48. For all positive integers. Okay, so this is the answer for the number 2. 6 marks. Now move on. We have question number 3. Question number 3. By considering the expressions over here, use the method of differences to prove this formula. So what you need to do is just follow the instructions. 2r plus 1 cube. So we can expand them by using the binomial expansion. So you will get this one as 8r cubed plus the 12r squared plus 6r plus 1. And similarly, 2r minus 1 cubed. If you expand them according to the binomial expansions formula, you will get the positive and negative alternately. So this is what you get. So we are having equations 1 here and equation 2 here. If you take the 1 minus with the 2, then you will get 2r plus 1 cube minus a 2r minus 1 cube. This equals to the 24r squared plus 2. So to find the sum of the same as the sum of this 2r plus 1 cube. The 2r minus 1 cube. So now to use the method of differences, you just need to substitute r equal to 1 inside here and here. You will get 3 cube minus 1 cube. Then when your r become 2, you get 5 cube minus a 3 cube. And when the r become 3, you get 7 cube minus a 5 cube. So you have listed down first 3 terms, and you can see the pattern that these 2 can be cancelled. And we are assuming that the pattern will continue. So we just need to list out until the last 2. So the last 2 here, last 2 terms will be 2n plus 1 cube minus the 2n minus 1 cube. So this will be 2n minus 1 cube minus a 2n minus 3 cube. Okay, so this is the expansion and this is the cancellation. So the cancellations, the pattern continue in such a way so that you will get this is equals to the 2n plus 1 cube minus 1. But your left-hand side, we need to do something with the left-hand side as well. So we need to expand them, break them into two series over here. Then we know that this constant, the sum of the constant is just a 2n. So this one is still remain as the sum of the r square, where the r start from 1 until n. Okay, so this is what we have. Then all I need to do is just to bring the 2n go to the other side. We don't expand this using the binomial expansion. We don't expand them, because if we expand them, it will be quite difficult for us to factorize it back. Because you can see that the questions actually, they want factorized form. So we try not to expand them. So over here, when you bring the 2n go to the other side, you can see that you can put it like this. And you can see that you have a 2n plus 1 is a common factor. So we will factorize the common factor out. So we just write sum of the r square. Take the 2n plus 1 out, divided by 24. I bring the 24 go to the other side, divide it. Then inside here, it will be the 2n plus 1. So if I expand them, then I will get 4n squared plus 4n plus 1 minus 1. So this can be cancelled. If we factorize the 4n out, so you get a 4 over 24n, 2n plus 1, n plus 1. So at the end, simplify it, you get 1 over 6, n plus 1, 2n plus 1. Proven. Okay, so therefore, we have proven this relationship. Okay, so we have proven this and done. Now we'll go on to the part B. Part B, they're giving you a series and they call it Sn. Okay, so the Sn over here, you can see the pattern is that when the terms is even, you can multiply by 3. And when it's odd, you do not need to multiply it by 3. So you can see the pattern. So over here, this is the pattern, and they all can be represented in such expressions over here. The general term, this is the general term. So basically, Sn is actually the sum of the r from 1 until negative 1 r square. Okay. However, if you write like this, it's not really helpful. It's not really helpful. Okay. So we need to figure a more useful way for us to represent them in terms of series so that we can find the sum. Now you can see the questions asking you to find S2n. So over here, you can see that 2n is an even number. It's an even terms. Okay, 2n is even terms. So the n over here, the n can be single, can be odd, can be even, but 2n definitely is even. Okay, so why they give Sn, and then the question want you to find S2n. Okay, so there's a catch over here. So you need to aware that, let's say, okay, you do not need to show this. I just explained to you all. So let's say we have 10, maybe, okay, let's say 10, S10. So S10 is actually 1 square plus 3 times 2 square plus 3 square plus 3 times 4 square plus until 9 square and 3 times 10 square. Okay, so right, if you follow the pattern by right, you're supposed to have the odd number will be like this and the even number will be like this. So what we need to do over here is actually we can look at them in such a way that we borrow the 2 square we write it like this. Plus 9 square plus 10 square. That means for the yellow color part over here, I borrow one of it out. I borrow one of it out. I borrow one of it out. Okay, I borrow one. So now after that, the remaining one, it will be 2 times 2 square plus the 2 times 4 square. 2 times 4 square, yes. And then after that, plus until 2 times 10 square. Okay. So all after you borrow it out, they become 2 only, 2 left. 2 times of the 2 square, 4 square, and 10 square, and so on. Okay. So now what you can see over here is that this we have 10 terms. How many terms we have here? We have only 5 terms. You can see this is half of it. Half of 10. Okay, yeah. So if you can understand this, then we can just make our questions here to become 2n. So if this is a 2n, then this will become, what will this become? If this is a 2n, then this will become 2n minus 1 plus the 3 times the 2n square. So this is the even. This is the odd. Then if we follow the same pattern like just now, we will have this as the 2n minus 1 square plus the 2n square. Okay. Then this one will have to do until 2n bracket square. Okay. So if we change the value here, become 2n. So how many terms we have over here? We supposed to have 2n. 2n terms. Half of it, half of the 2n, you get only n terms. You get only n terms. So that means the series over here, the sum is a 2n. The series over here, the sum is until n only. So what we need to do here, we can just write our we can write our S2n into this way. 1 square plus 2 square plus until 2n square plus the 2 times of the 2 square plus 4 square plus until 2n square. We will split them in such a way. So this will be blue and yellow. Okay. So they are going alternately. Then this is all yellow. But we don't use color. We don't use color to explain. So we just write like this will do. So this will have 2n terms. This one have only n terms. So you just write this one as a series of 2n. R from 1 to 2n. So this is the r square plus the 2 of the n of the 2r square. Okay, so this is what you're supposed to have. Okay, so we start from here directly. So the solutions for these questions B, we start from here directly. Okay. So this is the B. Then after you write like this just use the formula from part A. You can get this one as a 1/6 of 2n. 4n plus 1. This is a 2n plus 1. 4n plus 1. This one you can factorize the egg out and then you get this. Factorize the 2 square out, you get 8. Simplify it, you get this as a 1/3n. 2n plus 1, 4n plus 1. This one is you get 8/6 and n plus 1 and 2n plus 1. So you can see that we have a common expressions, n and 2n plus 1. So we just take the 1 over 3 out. Then we left with this 4n plus 1 plus the 4n plus 4. Simplify it, then you will get the answer that is 8n plus 5. So done. That will be the answer for the B, just like that. Now we move on to the C. C, they asking us to find the limit of n approaching to infinity of s to n over the n cube. So this will be the limit of n approach to infinity, 1 over 3n, 2n plus 1, and 8n plus 5. Divided by n cube. So what we can do is we factorize the n cube out from the denominator. You will get 1 here, you will get 2 plus 1 over n, and you get 8 plus 5 over n. You factorize n cube. Every terms you take n out. Every bracket you take the n out, take the n out, and take the n out. So total you have n cube. Okay, so divided by n cube, cancel it. So when the n approach to infinity, you will get 1 over 3 multiply 1, 2 plus 0, and 8 plus 0. You get this answer as 16 over 3. Done. This will be the answer for the questions 3C. And move on, we have question number 4. Have the plane pi contain the line R1 and R2. So find the Cartesian equations of the plane pi, giving your answer in the Cartesian form. It giving your answer in the ax plus by plus cz equal to d. So what you need to do is line number 1. Okay, I call this one line number 1. So r equals to the 3, negative 2, 1 plus the lambda of negative is r equals to the 4, 4, 2 plus the mu of the 3 to negative 1. So in order to find the normal vector of the plane, we will be taking this two directional vector and cross product of these two. Yeah. So you will get negative 2 minus 2, negative 4i. Okay, then 1 minus 3, positive 2j. And k will be negative 2 minus 6, negative 8k. So we can factorize the negative 2 out, make it become 2, negative 1, and then 4. Okay, so my normal vector will be 2, negative 1, 4. So your Cartesian equations of plane pi will be like this. So this is a x, y, z. This is your normal vector. This is your normal vector. And your fixed point, you can choose any position vector, either this point or this point. So it will be 3, negative 2, 1. So you will have 2x minus a y plus 4z is equal to the 6 plus 2 plus 4. 6 plus 2 plus 4 is a 12. So this will be a 12. So you get 2x minus a y plus 4z is equal to 12. So this will be the answer for number 4A. Done. Now we move on to the question number B. Part B. The line L passes through the point B with the position vector 2i plus 3j plus k and parallel to this. So we need to define the L. So the L look like this. So I had to be careful, okay. Because that's now I call L1. and L2, so it doesn't redundant, never mind. So they're using the lambda and mu as a parameter. So I will use t over here as a parameter. So directional vector is a 0, 1, 1. Okay, so they want to find the acute angle between the line L and plane pi. So over here, plane pi, it has a normal vector. So the line L has the directional vector. This is your directional vector for the line L. So the normal, you can refer back to the answer in part A just now. We are looking for the angle over here. But our dot product can only find the alpha. So we will just take the normal vector dot with the directional vector of the line. So this one is a 0 plus 1 plus 1 cos alpha. Okay, we find alpha. We want to find theta, but we find the alpha first. What is your normal vector? Normal vector need to refer back. Just now the normal vector is a 2, negative 1, 4. 2, negative 1, 4. Since they mentioned acute angle, we put modulus to be safe. So this one is a 4 plus 1 plus 16. So your cos alpha is equal to the modulus of 0 minus 1 plus 4 square root of 21 and square root of 2. Okay, so if you use your calculator, you get your alpha as 62.4 degree. So your theta plus alpha is 90 degree. So therefore your theta is 27.6 degree. So this will be the answer for the part B. Angle between the line L and the plane pi. Now we move on to the question C. Find the position factor of the foot of the perpendicular from P to pi. So we have a pi here. Okay. What is a P? P, this is a P. Okay. So let's say the P is somewhere here. So the P, the point P is okay, maybe we just write the factor OP. P is equals to the 2i plus 3j plus k. 2i plus 3j plus k. This is OP. So we are looking for position vector. This is the foot of the perpendicular from OP. So perpendicular from OP. So you can see very obvious we need normal vector. Okay. So the line OP, the line P, the line that contains the P is 231 plus S. The direction of the P, the directions of this line is parallel to the normal. Okay, so the normal will be 2, negative 1, 4. Okay, so we can make our, this one, let's say I call Q lah. So we let this one call Q. So this one I call Q. This point is Q. So let's Q will be the one that is combining the line together. This is the Q. So the this is the X, this is the Y, this is the Z. Okay, we will going to put the X, Y, Z into the equation pi. So this will be equal to the X, Y, Z. That will be equation 1. So the pi, just now the pi was 2x from the part A just now. 2x minus y plus 4z equal to 12, right? Let me check again now. Double confirm. 2x minus y plus 4z equal to 12. Yes. So that will be my equation number 2. 1 into 2. Okay. Then you will get 2x minus a y plus the 4z is equal to 12. So you get a 4 plus 4s minus a 3 plus s plus the 4 plus the 16s is equal to 12. So you have total of 21s is equals to the 12, 15 minus 8. 15 minus 8 is a 7. So you get s, parameter s is equal to 1 over 3. Okay. So put the s equal to 1 over 3 inside here. So therefore your OQ plus 2 over 3. 3 minus 1 over 3. And 1 plus 4 over 3. Simplify it. You will get 8 over 3. 8 over 3. Oh, and this is 7 over 3. Okay, so this is the answer for OQ, the position vector or the foot perpendicular from P, or you can just take the 3 out to make your expression looks nicer. Done. This will be the answer for the question number 4C. Okay, so now we move on to question number 5. Matrices over here. So we need to recognize the expressions over here. This matrix represents shear. This matrix represents rotation. So rotation, we know that the rotation, the matrix look like this. Negative sine theta, cos theta. So we can see that in order to get sub 2 over 2 and sub 2 over 2 here, that means your theta must be 45 degrees, okay, anti-clockwise. So what you need to do is that we need to state the type of the transformations here and then make clear the order in which they are applied. So this one will be first, after that followed by the matrix over here. So we just say that this is shear, the x-axis fixed with the point 0, 1 map to A1. Okay, because over here the original matrix is identity 1001 and it's mapped to 10K1. So this is what it means by the shear. So followed by what? Followed by rotation anti-clockwise. Rotation anti-clockwise about the origin through 45 degree. About origin to 45 degree. Okay, so this will be the transformation, the two transformation that is representing the M and with the correct sequence. So done number 5A, done already. Now we move to the 5B. We are having a triangle ABC in the XY plane and transformed by M onto the DEF. So we know that this is the object, this is the image. So we want to find in terms of K, the single matrix that transform the image back to object. Okay, so when the image transform back to object, we need to have a M inverse. but they want single matrix. So in order to get the single matrix of M inverse, so we can just multiply the M first. So your M look like this. Multiply by 1, 0, K1. Now we can see that the SAT2 over 2 is a common factor for this first, for the matrix over here. So I just factorize the SAT2 over 2 out. So I just expand, multiply them, leaving the constant like this. You will get 1, K minus 1, and then 1, K plus 1. That will be easier for us. Okay. So now we are looking for the M inverse. So the M inverse, we need to find the determinant M. So the determinant M, well, we can multiply this inside to make it become SAT2 over 2. SAT2 over 2, K minus 1. And then SAT2 over 2 and SAT2 over 2, K plus 1. And we can multiply them like this. Then we can find the M inverse. So the M inverse will be the 1 over the SAT2 over 2 square, K plus 1, minus the SAT2 over 2 square, K minus 1. And then these two value you swap. These two matrices you change the sign. Okay. So it's a bit troublesome. We can actually simplify it. So you get this one as the 2 over the K plus 1 minus K plus 1. So it's a 2 over 2. This one is the 2 over 4. Okay, sorry. We will be having the 2 over 4, then K plus 1 minus the K plus 1. This one you factorize as a 2 over 2 out. Then inside here remain as a K plus 1 minus 1. And then a negative of K minus 1 and then 1. Simplify it. You can see that this is a 2 over 2. So 2 over 2. And K plus 1 minus 1, 1 minus K, and then 1. Simplify it further. You can get this. Okay, so this will be the M inverse. This will be the M inverse. Okay, done for the part B. Now we move on to the part C. Find the set of value K which the transformations represented by M has no invariant lines through the origin. Has no invariant line through the origin. So over here, our M, I need to write down the M again. So the M just now was, this is the M. Okay. So it's a 1, 1. K minus 1, K plus 1. So we let our invariant line as a y equal to mx, then the image will be y equal to mx. So we take the m, multiply by the invariant line, which is x and mx, then you will get x and mx. So just expand them, you get 1 plus mk minus 1 Quite troublesome, huh? Okay, never mind. So over here, have to be careful when you multiply them. So this will be x plus mk minus 1x. This one is x plus mk plus 1x. So by comparison, you have 2 over 2 of 1 plus mk minus 1 x is equal to x. That will be my first equation. And the 2 over 2 of 1 plus mk plus 1x is equal to the mx. That is the second equation. Take the number 1 divided by number 2. This one can cancel. So you have 1 plus m of k minus 1 over the 1 plus m multiplied by is equal to 1 over m. So you get m plus m squared k minus 1 is equal to the 1 plus m, or maybe we can just expand mk squared, m squared k minus m equal to 1 plus mk plus k. So over here, mk plus m, sorry, mk plus m. This is a m squared. Okay, so the m and m here can cancel. So you will get m squared. You will get k minus 1 m squared. We're looking for m. So minus the km minus a 1 equal to 0. So you get something like this. So in order for you have no invariant line, so the question mentioned no invariant line, right? So in order not to have invariant line, then your discriminant must be less than 0. So that means your negative k squared minus a 4k minus 1, negative 1 must be less than 0. So you get k squared plus the 4k minus 4. Factorize it. We're not able to factorize it. Sorry. I thought we can factorize it. So we're not able to factorize it, then we have a problem. How do we solve this inequality? So over here, we just write it like this. Using the quadratic formula, your k is equal to the negative b plus minus of the b squared minus of 4ac minus of 4ac, it will be 60 divided by 2a. So this will be negative 4 plus 32. So 32, it will be 4 2 over 2. So this will be negative 2 plus minus 2 2. Okay. So over here, we can factorize it in such a way. So one is a k plus the 2 plus 2 2. Another one is a k plus 2 minus a 2 2. Okay. So from here, we can see that your k must be between these two values. Negative 2 plus 2 2 and negative 2 minus a 2 2. Okay. So therefore, your k will be between these two values. And move on. We have question number 6. Show that the curve with the Cartesian equations as given here can be converted into the r square equal to 36 cos 2 theta. So this one is polar coordinates. So we just need to know that r square is equal to the x square plus y square. And then r cos theta is a x, r sine theta is a y. Okay, just need to remember these three things. So from here, your Cartesian equation is this. So we make it become r square. This one is a 36 r square cos square theta minus a r square sine square theta. So your r power 4 is equal to the 36 r square cos square theta minus a sine square theta. So we should know that the cos square theta minus sine square theta is equal to cos 2 theta. So you get this. You cancel divide everyone by r square. Okay, so we just say that the r cannot be 0. So therefore, you get r square equal to the cos 2 theta shown. So this will be the answer for number 6A. Now we move on to the 6B. They want you to sketch the graph. So to sketch a graph, we just need to draw the table accordingly. So your theta from negative pi over 4. This one, negative pi over 4 is a 0 one. Then if we put pi over 4, you also get 0. So we need to have at least one value in between over here. When it's a 0 over here, you put 0 inside, you get 6. Square root of 36 is a 6. I think we need one more value over here. Maybe we can choose negative pi over 8 and positive pi over 8. Why we choose this? Because when we replace pi over 8 inside, you have 2 multiply pi over 8, you get pi over 4. So not up to you. It's not necessary must put pi over 8 and negative pi over 8. You can put negative pi over 6 and pi over 6 if you want. You can put it this. Because the question don't have any restrictions. So it's up to you. So over here I put pi over 8 and I press a calculator. I get 5.05 and 5.05. And if you are aware, you can see that these two are the same. So this is actually symmetrical. This will be your axis of symmetry. Axis of symmetry is where the theta equal to 0. So what you need to do here is draw with a proper scale, measure the angle properly. This is a theta equal to pi over 4. This is the theta equal to the negative pi over 4. This is the theta equal to 0. Then when theta equal to 0, you have a 6 over here. So this one at the negative pi of 4 and pi of 4 is a 0. So we can put in the theta equal to the pi over 8 and the theta equals to the negative pi over 8. So this will be 5 point something. So from here you can see that it's actually symmetrical. So it will be like this. Oops, didn't pass through the point. So it will be something like this and something like this. Okay, so you can see that they are symmetrical. So this will be the answer for the B, the graph for the C. Okay, so now we move on. We want to find the area of the region. So area of the region is half integrate negative pi over 4 to positive pi over 4 r squared d theta. So this will be half negative pi over 4 to pi over 4 36 cos 2 theta d theta. So this one is quite easy to integrate because we managed to integrate cos directly. So you will get 36 over 4 sine 2 theta from negative pi over 4 to positive pi over 4. So just use your calculator. You get 9 sine pi over 4 minus a 9 sine negative, 2 theta pi over 2. So at the end, you get 18 units square. So this will be the answer for the part C. Now we move on. We want to go for part D. Find the maximum distance of a point on C from the initial line. Okay, so from the initial line means this is the initial line. Theta equal to 0 is the initial line. So we are looking for the maximum distance, I max. So it will be dy d theta equal to 0. So we start from here. In order to get y, I multiply everyone by sine squared theta. So I get sine r squared sine squared theta equal to the 36 cos 2 theta sine squared theta. So this will become y squared equal to 36 cos 2 theta sine squared theta. Then differentiate implicitly. 2y dy d theta, 36. Keep the left, differentiate the right. Let's keep the right, differentiate the left. Okay, so we can actually factorize the common factor out. You get 72 sine theta. Then this one is a cos 2 theta, cos theta plus the sine 2 theta sine theta. Oh, sorry. I make a mistake. This is a plus. So this is a minus. Okay. So for maximum y, your dy d theta must be 0. That means that the 72 sine theta equal to 0. This one we reject. Because if it's equal to 0, then your theta will be 0. So that will be your initial line. So if this one we reject. Then another one will be cos 2 theta cos theta minus the sine 2 theta sine theta equal to 0. So this one, well, we actually can make this become cos 2 theta plus theta equal to 0, the addition theorem. So we have a cos 3 theta equal to 0. Your 3 theta is equal to the pi over 2. Okay. And negative pi over 2. Because our theta is pi over 4, negative pi over 4 because of this reason. So 3 theta, it will be 3 pi over 4 and negative 3 pi over 4. So your answer must be positive negative 3 pi over 2. Okay, so maybe we can combine them together, make it become positive negative pi over 2. So your theta is equal to positive negative pi over 6. Okay, so when your theta is equal to the positive pi over 6, what is your, we are looking for maximum distance. Okay, we're looking for maximum distance. So your y square, just replace it inside here. Okay, So you get 36 cos 2 pi, 2 theta. 2 theta will be pi over 3. And then sine square pi over 6. So this one is the 36 half 1 over 4. So you get 6. Is it? No, not 6. 36 over 8. 36 over 8, 9 over 2. Okay, you get 9 over 2. So your y is equals to the 3 over 2 or 3 2 over 2. That is your y max. That is your y max. Yeah. Then what about the theta equal to the negative pi over 6? If your theta is negative pi over 6, you still will get back the same thing. You can try. So you will also get 9 over 2. So your y max also will be 3 2 over 2. So you have only one answer. Why is that possible? That is because from the diagram, the maximum distance from the initial line, this is the maximum distance. This is also maximum distance. Okay, so this point, your theta is a pi over 6. At this point, your theta is a negative pi over 6. Okay, so for this reason, that's why both of the theta, either positive or negative pi over 6, will still give you the same answer. Okay, so actually we just need to show this one will do. Another one don't need to show, doesn't matter. Okay, so this one, if you don't show it, it doesn't matter really. Okay, but I just show to you for explanation purpose. So now we move on to question number 7. Okay, question number 7. The curve C is given as following here: 5x squared over 5x minus 2. Find the equations of the asymptote of C. So right here, what you need to do is, because we know that this one is the improper fractions, so we were going to have an oblique asymptote over here. So first of all, we find the vertical asymptote. Take the denominator out, let it equal to 0. So this is your VA. And for the OA, I will do like this. Take the five x minus 2. Okay, so we have plus the 2x. We will have, this one is the 5x minus 2 plus the 4 over 5. So from here, you will get this as the x plus 2 over 5 plus the 4 over 5 of the 5x divided by 5x minus 2. Okay. So this is your expressions after you reduce it to become proper mixed number, proper fractions after you make it become proper fractions. So your OA will be the y equal to x plus 2 over 5. Okay, so it's a fractions. Then done with the asymptotes BA and OA. Now we want to go for B, find the stationary point. So the coordinate of stationary point, we have the dy dx. So usually when we want to divide the x, we divide the x from here. That will be better. So differentiate from here, you will get 1 minus the 4 over 5 of 5x minus 2 squared. Yeah, you get 4 over 5. 5x minus 2 squared multiplied by 5. Cancel it. So you will get 1 minus the 4 over the x minus 2 squared. So your dy dx equal to 0. So it will give you 4 over x minus 2 square is equal to 1. So you have x minus 2 square is equal to 4. So your x, it will be equal to the 2 plus minus 2. So your x is equal to 4 and x equal to 0. X equal to 4 or x equal to 0. So when x equal to 4, what is your y? When x is equal to 0, what is your y? For here, very obvious, y is a 0. So your x, oops, sorry, my apologies, my bad. This is wrong. This is a 5x minus 2. Make a mistake. My apologies. So this one is a 5. So we will be having the 5x minus 2 is equals to the plus minus 2. Then your x will be equals to the 4 over 5 or x equal to 0. When x is equal to 0, your y will be very simple, just a 0. When your x is a 4 over 5, your y, just need to press a calculator. You will get this as a 5x square divided by the 5x minus 2. Okay, so press the calculator, then you get the answer as 8 over 5. So therefore, your stationary point are 0, 0, and 4 over 5, 8 over 5. So these are the two stationary points of the curve C. So now we move on to the questions part C. We want to sketch the C. To sketch a C, maybe we need to find the intercept. When x is a 0, we know that the y is a 0. When the y is equal to 0, actually no need to find because it's the same. X equal to 0, y equal to 0, y equal to 0, x equal to 0. So that means we have only one intercept. So that's why the question didn't ask us to find the intercept anymore. So what we can do here is draw it with a proper scale. I draw with a freehand, so my diagram is not with a proper scale. So you need to make the adjustment yourself. So over here, this is a 2 over 5. Okay, then this is also a 2 over 5. And this is a 2 over negative 2 over 5. Why we need to have a negative 2 over 5? Because we are having a oblique asymptote somewhere here. Okay, this is your oblique asymptote. Then you have a 0.00 as the minimum over here. And when it's 4 over 5, you get 8 over 5 here. This will be your minimum point. So if you extend make your diagram looks bigger a little bit. So your graph will be like this. And this will be the answer. This will be the behavior of the graph. Oops. Make sure you draw the features of the asymptote show the features of the asymptote clearly. Okay, so this one is the curve. Okay, so this is the graph. Okay, this is the graph where the y is equal to the 5x squared over the 5x minus 2. Done for the part C. Now we're moving on to the part, moving on with the part D. Okay, so over here, I think it's the 4 over 5. Okay, so now moving to the part D, we want to sketch the graph of a modulus of the graph just now. So modulus, that means this part have to reflect. All the one that is below the x-axis have to be reflect x-axis. Okay, so if you reflect about the x-axis, then your graph will look like this. So this one, it will be 2 over 5. This one is a 2 over 5. This one is a 2 over 5, negative 2 over 5. So the oblique asymptote also reflect. Okay, so this is a 0, 0. This is a 4 over 5. This is a 8 over 5. This part, no, not affected by the modulus. This one, after you reflect, then it will become something like this. Okay, so this is what we have. So then after that, we want to solve the inequality where the x is less than 2. So that means, first of all, we let it equal 5x squared over the 5x minus 2 equal to 2. That means we can split them, become two equations. One is a positive 2. Another one is the negative 2. So we have a 5x squared minus a 10x plus 4 equal to 0. And we have a 5x squared plus a 10x minus a 4 equal to 0. So over here, we need to use the quadratic formula. Negative b plus minus of square root of b squared minus a 4ac divided by 2a. This is also same. So we just need to use our calculator to make it become this. Another one plus minus. This one is a negative 1 plus minus of 335 over 5. Simplify them. Okay, simplify them. So this is what we have. So you can see that actually, if you imagine that your graph extend to somewhere very high, so when you draw the two here, you can see that you have a 4 intersection point. Okay, so these 4 intersection point, you have to arrange them in a proper sequence. So we need to know who is bigger. Okay, so we know that if you arrange them, so from small to big, this will be the smallest. And then the biggest will be this. And this is this will be this. So these are the sequence. Okay. So these are the 4 values over here. And just now remember, I told you that if I extend my graph, then I draw a 2 here. So I have 4 values over here, right? So these 4 values are the sequence that we have over here. These are the 4 values. These are the 4 values that we have over here. So what do we want? We want that the graph is less than 2. So the graph less than 2, that means it will be this region and this region. Okay, so according to what we have, these are the region that we want. We want the answer to be at this region. Okay, so I will erase away the color. I will erase away all these necessary things. I want to make my graph here so messy. Okay, so from here, you can just say that from the graph, okay, for the inequality, for this inequality of the modulus of the function less than 2, your answer will be, your x will be between -1 plus 3 sub 5 over 5, -1 minus 3 sub 5 over 5. And another one is 1 minus sub 5 over 5, and 1 plus sub 5 over 5. So you have 2 answers. Okay, done. So this will be the answer for question number 7, and this will be the last question for this paper. So I will stop the video here. I'll see you next time. Bye-bye.